Now we will start the chapter Introduction to Kinematics. So first let's talk about reference frame. So what is a reference frame? A reference frame is a coordinate system with respect to which position, displacement, velocity, acceleration, etc. of a particle is defined. There is no absolute frame of reference in the universe, as everything is moving with some velocity. Usually the frame of reference which is associated with the Earth, we consider it as an absolute frame of reference unless otherwise mentioned. So even though the Earth is moving, we consider it as an absolute frame of reference. Now let's look at some definition first. First we'll define position. Position is a vector quantity which is represented by vector r, and position of a particle is a vector with the tail at the origin of the frame of reference and head at the point where the particle is. So let's see this with the help of an animation. So as you can see in this animation, x and y axis is our frame of reference. This is the origin of our frame of reference. This is our particle. So the position vector of this particle would be a vector which has its tail at the origin and its head at the particle itself, and we represent this vector by r. So this is all about position vector. Now let's define displacement and distance. Displacement is also a vector quantity which is defined as the change in the position vector. So suppose a particle is at position vector r1 initially, and after some time it moves to position vector r2. Then the displacement of the particle will be given as vector r2 minus vector r1, irrespective of the path the particle takes while moving from r1 to r2. And the distance is defined as length of path from one point to another. Distance is not a vector quantity, it's a scalar quantity. So now let's see the difference between displacement and distance through an animation. So let's go through this animation first, then we'll explain what is displacement and distance. So suppose there is a particle which is initially at point A, and after some time it moves to point B. The position vector of point A is r1 and the position vector of point B is r2. So the displacement is defined as vector r2 minus vector r1, or final position vector minus initial position vector. So this is our vector r2 minus r1, and this is the vector which represents the displacement of the particle. Now distance is the actual path taken by the particle while moving from point A to point B. So as you can see from here, this curved path is the distance between 2 points. So distance is a scalar quantity and displacement is a vector quantity. There can be more than one path connecting 2 points. So distance between two paths may vary depending on the path being used. Also, the straight line path between 2 points give the magnitude of displacement. So let's say this with the help of an animation. So let's see this animation first. So as you can see here, the distance between 2 points A and B may vary according to the path being used. So like for the path which is represented by blue line, the length of this path will be different from the path which is being represented by the green line. Similarly, the path which is being represented by the orange line is different from the path which is being represented by the purple color line. And also the magnitude of displacement will be the length of the straight line between point A and B. So the red line here, the length of this red line will represent the magnitude of displacement. Now let's define average velocity. Average velocity is defined as total displacement divided by the total time of journey. So if total displacement is delta s and delta t is total time of journey, then the average velocity will be defined as delta s by delta t. Average velocity is a vector quantity because delta s, which is displacement, is also vector quantity, and we are multiplying a vector quantity by a scalar quantity which is 1 by delta t. Now let's come to average speed. Average speed is defined as total distance traveled by the total time of journey. So if the total distance traveled is denoted as L and the total time of journey is delta t, then the average speed will be L by delta t. So now suppose there are 2 points, point A and point B, and a particle takes this path to reach point B from point A. So the length of this path is L. Then the average speed will be L by delta t, where delta t is the time taken by the particle to move from point A to point B. Now what will be the average velocity? Average velocity will be the displacement between A and B divided by the total time of journey. So displacement between A and B will be a vector from point A to point B, as we have already seen, and the magnitude of this displacement will be the length of the straight line connecting point A and point B. So suppose this vector is delta s, then average velocity will be delta s by delta t. Now let's see what is the relationship between average velocity and average speed. So suppose there are 2 points, point A and point B, and a particle takes this path to reach point B from point A. Let's denote this path by P1. Now suppose the length of this path is L, and the particle takes delta t time to reach B from point A. So delta t is time of journey. Now in this case, the average speed would be length of the path P1 by total time of journey, that is L by delta t. Now what will be the average velocity in this case? So average velocity is defined as displacement between A and B by total time of journey. So the displacement between A and B would be a vector from point A to point B. This is delta s vector, which is displacement, and the magnitude of average velocity would be the length of this straight line, which let's say it's L1, by total time of journey, that is delta t. So magnitude of average velocity would be L1 by delta t. So as we know that the straight line is the shortest path between any 2 points, so this means that L1 is always less than L, less than or equal to L. So we can say that the magnitude of average velocity is always less than or equal to the average speed. So this is the relationship between average velocity and average speed. Now let's define instantaneous velocity. Instantaneous velocity is defined as the rate of change in displacement. Instantaneous velocity of an object at any given instant is same as the average velocity of that object in very small duration of time around that instant. So let's see more of instantaneous velocity. Suppose there are 2 points, point A and point B, and a particle travels from point A to point B using some path. Now suppose we need to find the instantaneous velocity of that particle at any given instant t. So suppose at time t, particle is at point A1. So to find the instantaneous velocity at this instant, that is at the instant t, what we'll do is we'll take the position of particle at the instant t plus delta t, where delta t is very small time duration. So suppose at the instant t plus delta t the particle is at point B1. So the instantaneous velocity of the particle will be given as limit delta t tends to 0 delta r by delta t, where delta r is the vector between point A1 and B1. This is our delta r. So this expression is nothing but the derivative of displacement vector with respect to time. So this is our instantaneous velocity. Now let's move on to instantaneous speed. Instantaneous speed is the rate at which the distance is travelled at a particular instant. It's the same as the average speed of an object in a very small duration of time around that instant. So suppose if an object travels a distance of delta L in a very small duration of time delta t, then the instantaneous speed can be defined as limit of delta L by delta t, where delta t tends to 0, and we know that it's equal to dl by dt. Now the distance travelled by an object in very small duration of time will be very small, and even if the object's path is along a curve, for very small length this curve can be approximated to a straight line segment. So instantaneous speed will be same as the magnitude of instantaneous velocity. Now let's see how this is possible. So suppose an object travels from point A to point B along some path, and we need to find out the instantaneous speed at some instant t. So let that at instant t the object is at point A1. So to find the instantaneous speed at this instant, what we'll do is we'll take the object's position at point t plus delta t, and let's suppose that at this instant the object is at B1. So as you can see that if we keep delta t very small, then the length of A1 and B1 would be very small, and even if it's on a curve, we can approximate the segment A1 B1 as a straight line segment. So in this case the magnitude of displacement, that is straight line between A1 and B1, and the magnitude of distance, that is length of the curve between A1 and B1, will be approximately equal, because we have made delta t very small, and so the segment A1 and B1 can be approximated as straight line. So that's why instantaneous speed will be equal to instantaneous velocity. In fact, it will be equal to the magnitude of instantaneous velocity.